Hello and welcome to another free code session. My name is Jason Bach. I'm a little excited because I've got even potentially better performance in rocks with the initial work I've been doing with this forward-only linked list. So the next thing I want to do is add in some benchmarks on for each enumeration, comparing what I did with a list. So let's dive in. So let's come back up here to performance, and what we want to add is handler lists enumeration. We'll call it that, handler lists enumeration. Now in this case, I'm only going to do in fact, it doesn't matter about initial capacity. We're not testing how fast it takes to add things. We're testing just the enumeration part itself. So we don't need to do any of that, which is good. Let's get that up. Yes, we do. Okay, because I want to make a data thing. And in here, what we're going to do is say static. Well, in this case, I have to do two of them, list data and handler data. You'll see what I mean in a moment. So I want a list of handler, and we had this, we want to share this just because handler int, so I don't have to make my own. We want a handler int, static list handlers, generate int size. And so what we're going to say here, again, the initial creation of it doesn't matter. Var handlers is equal to new list handlers. In this case, we're going to set the capacity because we know what it's going to be. For var I is equal to 0, I less than size, I plus plus. We're going to say handlers.add, and we want to say new handler int, where we say, where was it? Input is equal to I, just because we can. And then we're going to say return handlers. And the reason I do that is because I want to say you'll return your new object, generate of 1. And you can see where this is going to go. Generate of 2, generate of 5, and generate of 10. Okay. We also want a list of, well, list data, handler data. Now, the thing that just went through my head is we've been able to say add default. We'll have to try it. We'll have to try and see how one compares to the other, because I do not want the generation of the data itself to be a part of it. So here we're going to say new handlers is a handlers. I still don't quite like this because it feels like just the naming for this is a little, we want to do, yeah, I was lamenting about this because the signature is a little funky, but it's all going to be generated, so who cares? So now here we can do is say new handlers of right, and then we pass in a new, yeah, we're going to do one of these. So we're going to make that 0, and then we're going to say from I is starting at 1, and then we do that. And then this will be that. So we're going to return that. And then we return those. Okay, so now we've got that going for us. Yeah, you're complaining because benchmark base, no. Base. Oh my God. Thank you. Public int enumerate list of handler int handlers. And I'm going to try to do something very simple here. I0 return I for each of our handler and handlers. I plus plus. Now, why are you... Oh, for God's... What? Shut up. I do not need you right now. Are you serious? What is the problem here? No. Unreal. Sometimes I don't understand why it will kick in some cases and not in others. And it's just like, shut up. Go away. I know, I of all people, love code analysis, but in this case, I know what I'm doing. Please stop it. But, oh well. Enumerate list. Now we're going to say enumerate handlers. You ever make mistakes when you're typing and you're like, yes, I know exactly what I'm about to do, and you do it anyway, and you realize, oh, I just screwed up, and yeah. And that should be the same thing because it implements that. The thing is, what I want to do is say like I plus equals handler, and then there should be an input dot. Is there a... Yeah, you can't get the value. That's right. You can't get a value from the argument that you make. You just validate it, and if you gave it a value, it checks internally if that value is what you gave. So, which makes sense. I mean, because you don't need to check the value once you come out of it. Especially if you're doing a delegate for validation, there wouldn't be a value. So the best I can do here is what I had. Best is arguably is potentially lifting a lot of weight there. But what I want to do here is before I run the tests, so if we come back to program here, I'm going to grab this and handler lists. We're going to put in here a thing to say to test, do that. So we keep the test code that we want if we want to test it in a comment above, and that's sufficient. So now in the program here, what we want to do is say what we kind of just did down here. What I want to do is say var lists is equal to, we'll just do that. That's fine. Handlers. Okay. And then we'll say handlers.add of 1. Why are you barking? Oh, okay, whatever. For each var handler and handlers, what I want to do is say console.write line handler, and then we'll say handleless enumerations, but we're not going to run that right now. I just want to see what this does. I want to make sure that I'm actually going through the two that I have. And this isn't unexpected. It would just do the toString on it because I don't. So I'm going to have to put a breakpoint here because I want to kind of like dive in. And then I got to remember to change this back to release because otherwise benchmark.net won't run. So we have the input being, oh, I was looking at the wrong thing. Yeah, I want to see the input value is that. And then the second time we come through, it should be an argument of 1. Yeah, actually, I could have, if I come back here, and instead of doing I++, I wonder if I said I plus equals handler dot value, no, input dot, oh, maybe you can't see that. That's right. You can't, just like John Cena, you can't see it. So that's good. I think this is good for now. As good as it's going to be. I know I saw 2, and that's what I expected. So what I'm going to do now is run this code in release mode. Did it go to release? Yes. And we want to do that one. So I'm going to pause recording, and we'll see what we see. This is probably going to take a while, but that's okay. Let's see what happens. Okay, a couple of whoopsies. I forgot that I didn't need to return an array. I just need to return an object and then return that, and that works. I probably could return the actual type, but it really just matters that it casts that correctly and goes through. I might change that when I run it, but that was it. I forgot to take the benchmark baseline off of one of them, and now it ran with just one. So now I should run, now I'll be able to run it, I think, and hopefully everything should work, and I should be back with results. This is why you test. This is why you benchmark. And actually the ratio here, it doesn't matter because it doesn't make sense to have a ratio between the two. But it's interesting that one is returning 70. That's a little odd. I don't understand. I think this is the type. This is that. I'm not sure what these values here mean. They wouldn't be tied to the return value or something like that. I really don't know what that is. Maybe a little bit more work to do. But it is clear that the list is much faster at enumeration than the handlers is. And we're also allocating 48 bytes for enumeration, which is really interesting. I am curious. List of T. What does that actually do for enumeration? Get enumerator. Well, that's just the constructor. We don't really care about that. Returns an enumerator for this list with the given permissions. Blah, 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 blah. What we really care about is done here, and then we do a new enumerator. Well, what does that do? That takes a list, and it actually implements these. But looking at this, you'd think this would actually be slower. Unless I don't understand how the list actually does what it needs to do. Well, slower. I mean, the thing is, with the way I have it built right now, no, not that, handlers, is I'm using yield return. And I know yield return has some baggage, not much, but some. And so if this is a numerator, we're doing enumerable. So actually, let me think about this for a second. Come on. Where am I? Here I am. If I did this and I said I enumerator of that, you're going to say, yeah, you don't implement that, which is fine. We're going to take that off. This is what we're basically replacing. So let's say implement it. Now here's the tricky thing. We've got these three things to do. So if we want to enumerate this, we have to keep what is the current enumeration, and reset would set it back to first. Wait, if I take these out, Let me comment everything out here because I want to make sure I know exactly what it is that I'm supposed to implement it. Yeah, and now you don't know what those properties are, but that's fine. So all you need is move next and reset. Okay, so let's put these back in. And now we're good because we've implemented. I don't know why I did all the other ones, but who cares? So move next. Wait, that doesn't make any sense. If I go to the definition of this, there's also a current. So yeah, that didn't implement everything. Unless there's a count first last. Where's the... Oh, you put current up there. But we're doing a enumerator. Oh, is that from this one, I believe? Yes, that's the oldness. So, okay, wait a minute. We're going to take, it's right there, Jason. I want to group them all together so that I know what's what. So we say dispose. So we need to get the current. We need to get move next and reset, which makes sense. So what we could do is say, on a reset, you start to first. On a move next, you go to the next. On the current, and move next would have to say if you can actually move next. I believe that returns false if you can't move next. I believe. So now, unfortunately, we have to keep track of 3 things. But that's okay. First, this dot current equals handler, and this dot last is the current is only for, well, it is actually private, yeah. So that's fine. Okay, so our current value here would be this dot current. Oh, yeah, I see what it's getting screwed up on. So current value. I can clean that up later. Okay. Dispose, we're just not going to do anything right now. Just leave it. Current can also be this current. There may be a thing where you say don't do that, but now move next. That one's a little bit more involved. We say here, this dot current value is equal to this dot current value next. If, and then you return this dot current value is not null. And that means that we need to be smart about when it's, yes. We always want to return okay, I think we say you always return the current value. Now here, we would want to say if is null, return false. Otherwise, we do this because if it's null, we just return. If we do this, we reassign. We know it's not null, so we can say return true. Okay. And reset does this dot current value is equal to this dot first. So we go back to the beginning of the list. Simple. Now, of course, if this is better with the enumeration, I would need to run the other one again because I think that would slightly up the memory a little bit. Maybe, but again, it's definitely better for performance. It's better than what we're doing right now, and even if we did 2 capacity, it would be better. It's always better in terms of memory. So even if it did like one tiny thing, just wafer thin, if you caught that value, caught that reference. Okay, I think this is now correct in what happens if we do handler lists. Can it still do a for each on it? It should, because, yeah. This is actually probably a little bit better. Let's go into our program and let's see what happens now when we do this. So if we say this, and then, oh, that's fine. We wouldn't do collection initializer simplification. That is not a word. There. Okay, and now you realize you can't do that, so that's fine. But what broke here? Oh, fine, whatever. Whatever, I don't care. Using that. Okay, now let's put a breakpoint here. Let's come up here. Let's do debug. Did this iterate correctly? Well, you can't if it's only read-only. What did I do here? Oh, current value. And the current value is just the current value in the enumeration. So you only change that if you're doing the enumeration things. So we don't have to worry about it when you're adding. In fact, you shouldn't add if you're enumerating. But again, just trying to see how this works. So no, that would have been recursive. That would have been bad. Current value, current value, current value, current value. Yes, current value. Okay, now what? What's the problem here? Current value. Just return the damn thing. Okay, okay. Now let's run it under the debugger. Okay, so we get 1 with the value of 0. Step through. What's handler now? Handler is an input of 1. Okay. So I think, I don't think it failed. Yeah, I mean, it was kind of weird because it didn't go down to a next value, but yeah, there's no error here. Okay, so now I'm going to go back into release mode. Yes, and we're going to comment this out. Yes, actually, let's do this because we're going to capture that as potential code. Now we say list enumeration, run it. I will see what it does now, if there's any improvement at all. Well, I ran it again. It is faster. So the set of benchmarks below is what it's doing now. I don't understand, though, how it is that much slower than a list. I mean, I know a list has got all the highly optimized stuff, but when I was looking, again, through this and how it does the enumeration, just to go through this again, if we say get enumerator 0, otherwise, if we do something, we call this, which calls get enumerator this, which passes in the list, and it's move next. And like I'm looking at this going, there really isn't much different than what I did before, than what I did. They even have a move next rare. That's funny. So they just index into their list, which I guess that could be a really fast operation. And what I'm doing here, when you say get enumerator, I would assume you're using this one, right? You're not using yeah, that's the only one you could get. So, and it's working. So, oh, wait a minute. Wait a minute. I think I screwed up. I was going to stop the video here, but I think I screwed up. Let me just real quick, if I come back in here and I say debug and close, what I want to see is, which one do I get into? Because there's something in the back of my head going, I think if you have a signature like this on your method, on your type, it does this kind of like duck typing thing and says, oh, I'll just call that. Now, I could be wrong in this, but the fact that it really didn't change much makes me kind of wonder. So let's just go through this. I want to see what this does. Yeah, it's going through this. It's not even doing what I thought it was supposed to be doing. So hold on. Let's stop here. Let's not do that. And so now that should force the hand here. Yeah, now it doesn't know how to enumerate. So actually I'm going to stop here because I think I've gotten close to or over the time I usually want to do. I'm not ruling this out just yet. I think there is a way to do this. I don't have the right pieces plugged in together just quite yet. So in the next video, what I'm going to do is show you the results of my off-camera work and trying to get this to work, and does it actually get any kind of better. So in fact, I should have caught this. The last one was like 12 to 15, and this was 60 to 44. Like, you know, and the allocations were the same, and there shouldn't have been an allocating. So good thing I caught that. So I'm like, I still haven't completely ruled this out. We'll see what happens in the next video. Thank you all for watching. Leave comments and questions below. See you in the next episode.